Hello, everybody, and today I want to talk to you about the volume of pyramids, and the volume of spheres. This video will use the thing that I talked to you about last video, or was it the last video? I think it was the last video. The surface area of a sphere. So now let's get on with the things that I want to talk to you about. Now, firstly, the volume of pyramids. Now what we are going to do is imagine what's it called? Something like a cube with rectangles. I forgot what it was called. Anyways, the cube thingy with rectangles, and now what we are going to do is imagine something like this. This is, wait a second, let me draw that thing. And we are going to think of a pyramid that is in the rectangle cube thingy, like that. And we are going to have another one that is facing it like that. These have the same volumes, and this point where the meeting point of the two pyramids is the half of the height. Here we are going to call it Z, and this is going to be X, and this is going to be Y. And so firstly, the volume of the oh wait, of course the height is Z, whatever. Firstly, the volume of the rectangle cube thingy is X, Y, Z, all multiplied. Now we're gonna have a pyramid constant, and we are going to call it K here. So now the the volume of the pyramid is going to be K, X, Y, Z divided by 2, because the half thingy over there. But what we are going to do is count these both. So multiplied by 2 equals K, X, Y, Z. So these both combined is K, X, Y, Z. It has a volume of K, X, Y, Z. Now what we are going to do is not imagine these ones, and what we are going to do is think of different lines, different pyramids. So the rectangle cube thingy is like that. It's a bit flattened out, but just it's a same thingy, same rectangle cube thingy, and there's a middle spot. And we are going to think of the pyramid pyramid that is facing this direction. So this pyramid, and the pyramid right behind it, this one, the one that it's facing that way. So now this part is going to be a half of an X, and this is gonna be Y, and this is gonna be Z. This is not 2, it's a Z. Let's draw the 2's like that, so we won't mistake those 2. Okay, now, so these 2 combined will be, firstly, half of an x multiplied by y multiplied by z. But we have 2 of them, so we multiply 2 to it. So this 1 over 2 disappears. So this will be again, well, there's the pyramid constant thingy, so we have to multiply that too. So these will also become k, x, y, z. And now the last part, I'll draw it here. Now again, I'm basically drawing the same lines, but we can think of 6 pyramids in it. Now we looked at these 2 and these 2. So now we're gonna look at this one and this one. So the pyramids facing this way and this way. So now that would be and half of a y and a x and a z. Now, okay, so again we're gonna do something like a half of k x y z, and again there's 2, so multiply 2, and that would become again k x y z. Now, so there's 3 k x y z, and the thing is, all of these combined is x y z. So x y z is 3 k x y z. So xyz is 3 k xyz, so k would need to be something that makes the 3 disappear, basically. So the obvious answer would be k equals, so the obvious answer would be k equals 1 over 3rd. And that's why you get volumes of pyramids by doing this. Firstly, well, let's imagine it's a very badly drawn pyramid, but anyways, there's a pyramid, and you think, and you also, let's try it again over here. We have a pyramid here, and what we normally do is draw a rectangle cube thingy surrounding it. So we have something like this here, and what we do to get the volume of the pyramid is, as you might know, multiply this part, and the height of it, and then multiply, and then get a third of it, 1/3 of it. And the reason for that is this thingy, because xyz is 3kxyz, and k is 1 over 3. So that's why we multiply this number to the rectangle's square thingy. And this is true for all other horn-shaped things. You can think of that as just, it's for the pyramids, and so, well, I guess it's the same thing to everything else. And now, so the volume of pyramids are a third of xyz, and now the volume of spheres